We're going to start talking about something called wrapping functions. Wrapping functions are the basis of trigonometry and something that we'll refer to as the unit circle. In order to understand the unit circle, though, I think it's best to start off with these functions that we call wrapping functions. And if you notice, it's wrapping with a W, not wrapping with an R. It's not the musical function. But you can have some fun with that if you'd like. So a couple other things to talk about. A wrapping function takes the real number line, originating from the origin, and wraps it around a shape, any shape. Eventually, we're going to work our way up to circles. It wraps in both the clockwise and counterclockwise directions. And notice clockwise, right, if we're going from the origin, clockwise goes this way, this is counterclockwise, which is the positive direction. Right, so counterclockwise is positive, and clockwise is the negative direction. Okay, so again, this line right here represents the number line, the real number line. 0, 1, 2, 3, 0, negative 1, negative 2, negative 3, so on and so forth, forever. Okay, and it's going to take imagine you're wrapping a gift, right, and you got that annoying little brother, that annoying little sister, and you just want to wrap their gift, which is this little tiny box, and you just want to wrap it 1,000 times. Right, he's going to keep going around and around and around and around and around. Well, that's what number line does. It keeps going around and around and around, but it goes around in both directions. All right, so in this example, you always need to be given some information here. A wrap of 1 gives you the coordinate, right? A wrap of 1 results in the coordinate, in other words, the xy ordered pair of 1, 1. So that means that this point right here is the point 1, 1. And likewise, a wrap of negative 1, right, in negative direction, gives you the coordinate of 1, negative 1. So now we have some scale going along because this is given information. Given info provides scale. And that given info may be on the diagram, it may be on a grid, or it may be written off to the side like this is right here. Now I'm gonna shrink this down a little bit just so we can see the questions below in addition to what's here. See what 100% does. Yeah, that looks like a winner right there. So we got the questions below, right? The different wraps, and we have the graph here as well to look at. So a wrap of 4. This is as easy as counting. First of all, it's positive, so we have to go in the counterclockwise direction. We go 1, 2, 3, 4. There is a wrap of 4, and a wrap of 4 gives us the coordinate 0, negative 1. So there's our answer. You don't need to write that C every time. This is just kind of notation to help you remember that's a coordinate. So we're traveling around the perimeter in order to find what location on a Cartesian coordinate plane on a graph that we're on. Again, we're going around the perimeter to find our point on a graph, our XY coordinate on a graph. A wrap of 2, well, that's 1, 2. Puts us at 0, 1. And off to a good start here. This is negative 1, 0. Yeah, it's early. Don't use that excuse. That's a bad excuse. Negative 1, 0 is there, right? This guy was negative 1, 0. A wrap of 3, 1, 2, 3. So that is negative 1 on the x and 1 on the y. A wrap of half, well, that seems difficult. No, it's not. We already know we're out here at x is 1. If I'm going up halfway, y is a half. 1 comma half. A wrap of 6, well, I already know this is 4, so I'm not going to count that again. 5 and 6, 0, negative 1. A wrap of 10, well, that's interesting now. So that's 4, 5, 6, 7, 8. Again, I'm going around, 9, 10. So a wrap of 10 is equal to a wrap of 2, which was the point 0, 1. Right, a wrap of 2 got me to the same location as a wrap of 10 did. We'll keep that in mind for a little bit later. Think of that as somebody in the Olympics and they're skiing or skateboarding and they do a 360 and then somebody comes up and does a 720. So they went around twice in the air. But if you only saw the beginning and the end and you didn't actually see them spinning in the air, you can't tell any difference. They started at the same spot, they ended at the same spot. What they did between was different. So a wrap of 2 and a wrap of 10 end at the same spot, but they have completely different methods or means of getting to that spot. Right? That's that second layer of wrapping paper you put on your brother's gift. Okay, it's going to cause you more joy watching them unwrap that thing. And they're only being like newspaper inside. All right, a wrap of 14. So we've already established this is not only 2, but it's 10, 11, 12, 13, 14. Wrap of 14. I already have a dot there. That means I did this one already. That's 0, -1. So a wrap of 14 is the same as a wrap of 6. So 2 and 10 are the same, and 6 and 14. 2 and 10 and 6 and 14 are the same. Okay. Keep it in the back burner. A wrap of 27. Huh. Well, now I have an idea. If 2 and 10 are the same, that means 18 is probably the same as well, and 26 and 34. Following me here? What am I counting by? Think about that. 1, 2, 3, 4, 5, 6, 7, 8. A wrap of 0, right? The starting point is equal to a wrap of 8, which means that's equal to a wrap of 16, which means that's equal to a wrap of 24, which means that's equal to a wrap of 32, which that's equal to a wrap of 40, so on and so forth. So if I'm trying to do 27, I'm simply going to go 8, 16, 24, 25, 26, 27. A wrap of 27 is -1, 1. A wrap of 34. So that's 32, 3, 4. 0, 1. Now we're talking negatives here. Well, I know it's 8 around in the positive direction. That's going to be 8 in the negative direction too. So a wrap of -7 whoosh, is right here. 1, 1. Which I could also say is a wrap of 1. Okay, but again, we're looking for the coordinates. The coordinates are our answers. I'm just showing you different wraps it's equal to. A wrap of -12. Well, if this is -8, 9, 10, 11, 12, -1, 0. Wrap of -30. Well, I know -32, right? 8, 16, 24, 32, -31, -30 is right there. 0, 1. -36, well, that's -32, right? If I keep going around, zoom, 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 -32, 3, 4, 5, -36, -1, 0. 3.5, oh, here's this half guy again. Well, no big deal. 1, 2, 3, and a half. So the x-coordinate is -1, the y is a half. And a wrap of 0.2. Well, x is 1. And 0.2 is going to be like 0.2 up. I'm going to write that as 1/5, though. I prefer fractions. All right, so it's not too terribly bad. Now keep in mind this is a box, so really easy to count. This next one we're going to look at has a slight little twist on it, but not too much. And I'm only going to do a couple of these and then move on to the next example here, because I think you guys will get this one no problem. So given information, a wrap of 0 is 5, 0. So a wrap of 0 is 5, 0. Boom. That's my starting point. We always start on the positive x-axis. Always begin on the positive x-axis. Always, 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 always. And a wrap of 1 gives me the point 5, 1. Okay, so that's given. That's pretty obvious there in this situation. So again, I'm just going to do a couple of these. A wrap of 3. Well, I'm going to go. Remember, this is talking about perimeter here, so you have to pay attention to your scale. Each box represents a distance of 1, so I'm not jumping up to the corner like I did in the last graph, because I had a different scale. So a wrap of 3 is 1, 2, 3. That's the point 42. I'm going to jump over to wrap of 15. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. -1, 3. A wrap of 20. Well, that's 15, 16, 17, 18, 19, 20. And I'm going to start making some notes out here just so I don't need to count all the way, because I see things like 47, 269. I'm not going to want to count over and over and over again. This corner is -5, 2. And a wrap of 40. Well, if that's 20, 21, 22. So 22, that's good to know. Right there's 22. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I kind of lost track of what I was doing here. 22, 23, 24, 25, 26, 27, 28, 29. This is 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. 40 puts me right here at the corner. So there's 40, which is 5, negative 2. So at this point we can define something new. It takes me 42. A wrap of 0 is the same as a wrap of 42, right? 2 more takes me back to the beginning. That is what we call the period. The period is 42. How long does it take you to get around? How much is the perimeter till you get around? In this case, it's 42. So I'm going to let you on your way with the rest of them. I'll do number 5 here actually real quick. 47, well, it's going to be the same as 42 plus 5. 1, 2, 3, 4, 5, 2, 2. Okay, 269. Fiddle around with that guy. Enjoy. And now we're going to get to something that's not quite as obvious. Again, we got our given information, the wrap of 0, that gives me the point 8 comma 0. Positive x-axis, right? And a wrap of 16 is 0, 0. So 8 and 8. This guy here, they're saying, is 8 as well. I'm sorry, the whole distance here is 16. I was not thinking correctly there. Okay, well, this is 1, 2, 3, 4, 5, 6. That's 6. Right? If this is 16, that means this guy's 10. So we can either trust that it's 10, or, we can use a little bit of math here. If this is 8, right? This distance right here is 8. We counted this to be 6. Pythagorean theorem says this is a 3, 4, 5 triangle doubled. 3, 4, 5 doubled is 6, 8, 10. This one here is 1, 2, 3, 4, 5, 6 by 8 by 10. It looks like all of these are 6 by 8 by 10. 6 by 8 by 10. 1, 2, 3, 4, 5, 6, 8, 10. Yep, it is. So when I'm going around this guy and I'm doing 26, I'm doing 6, 16, 26. Boom. 6, comma, 8. Now let me look at one example where we might happen to fall in the middle here. Let's say I fall here in the middle. What is that coordinate? Well, that one's easy, so let's not do that one. That's actually right smack dab in the middle. Let's do one where you need to go, I don't know if it's on here at all, but let's say a wrap of 20. That means I'm going to come up here 4. I don't know where 4 is because this isn't on an angle. I know 4 up, I know 4 over. I don't know 4 on the angle. But I know 4 is less than halfway. And if I'm doing this somewhat to scale, let's say 5 is right there, so 4 is somewhere around here. It looks like 2 comma 3. But we don't know for certain that it is 2 comma 3. But what we do know is that's 4. And the whole thing was 10. So I have 4/10 of this side. Well, if this whole side was 8, I have 4/10 of that. And if this whole side was 6, I have 4/10 of that. Okay, so in other words, I have 2.4 as my distance here. My horizontal distance would be 2.4. And my vertical distance would be 3.2. So my coordinate would be 2.4, comma 3.2. Okay, and if you look at it, my dot's actually kind of close to that, 2.4 and 3.2. So we can use the fact that we have similar triangles and proportional triangles in order to find things that happen to be in the middle. All right, so domain and range. Let's take a quick peek at domain and range. Domain are our inputs. Domain is always our input. Well, I can do a wrap of anything I want. My domain is all real numbers. Range is my output. I have two different outputs. I have an X output and I have a Y output. All right, my X's range from -8 to 8. I cannot get a value other than something between -8 and 8. Okay, we saw I can get decimals. I got 2.4 and 3.2. Right, 2.4 is the X. So I saw I can get decimals, so that's possible. Okay, but I can't get a 9 because there's no point on here anywhere that x is outside of 8. And likewise, my y's in this particular case are also negative 8 to 8 because the lowest it goes is negative 8 and the highest it goes is 8. So be careful. Your range is a set of coordinates, an x and a y output. That's about all I'm going to show you today with wrapping functions. There's one more on the back here that you can start yourself, very similar to the one we just did. Think about Pythagorean theorem, square root of 2. We got 1 and 1, a squared plus b squared equals c squared. Don't let the square root of 2 fool you. This one's actually not too bad. We'll pick up on this on another day. Enjoy.